Okay, so now we're going to continue looking at these questions, of course. We're going to have t times the t derivative of u plus the x derivative of u is equal to 0. Okay, so now this is our first example where these coefficient functions are not just constants. And we're going to have u equals 1 plus 2t, and this again is going to be on the t-axis. Okay, so the parameterization again will be 0 t naught, and this is for t naught in the set of real numbers. So x prime is whatever is multiplying the x derivative of u, that's 1. T prime, whatever is multiplying the t derivative of u, that's t. Z prime is going to be the right hand side, that's 0. X of 0 is 0, t of 0 is t naught, and z of 0 is going to be 1 plus 2 t naught. Okay, again, we have a pretty simple system of equations. All of our systems so far have been decoupled, meaning like we don't have x prime depending on t, or t prime depending on x. We'll get to cases where that's no longer going to be true, but not yet. So x of s is equal to s. Okay, so t of s, we have t prime is equal to t. Well, it's going to give us an exponential function. We know the solution is going to be equal to t naught e to the power of s. The hardest part here is just realizing that t is the dependent variable and s is the independent variable. And then z of s, well, z prime again is constant, just like everything except for the previous problem. And so z of s is just going to be 1 plus 2 t naught. Okay, so let's think about graphing some of these. So let's think about graphing some of these. This is, when I say some of these, I mean the characteristics. This is the x-axis, this is the t-axis. Okay, let's say I'm going to take a generic point here. I'm going to call it t naught. Okay, what is my parameterization? Well, the horizontal is s, and the vertical is t naught e to the s. So it's just going to be the graph of the curve, or the graph of the relation, whatever you want to call it, t is equal to t naught e to the s. So it's going to be an exponential curve. So we're going to have stuff that looks like this. Okay, and then as we come down, the exponential is going to get shallower and shallower as that goes to 0. When t naught is equal to 0, I don't want to. If I rub the purple on the black, it blends both of the colors. So just this axis here corresponds to the x-axis corresponds to t naught is equal to 0. And then notice what happens if we're negative in the negative t-axis. We're going to have a downward facing exponential curve. So something like this. And these both go on. Okay. These aren't the greatest curves, but they both go on for infinity that way. Okay, this will be for a different t naught. Okay, now z is constant, so it means on each one of these curves, u is equal to 1 plus 2 t naught, just whatever it is there. So here, u is equal to 1 plus 2 t naught. And again, I hope it's apparent here that every point in the xt plane lies on a characteristic, on one characteristic, and every characteristic intersects the t-axis exactly once. Okay. So now what I want to do is if I take a generic point here in the plane, let's call x of t, I want to know which characteristic it lies on. In other words, if I look at all of the characteristics, I want to find the one that passes through it. This is going to be my t naught here. Okay, and so I know u at this generic point, xt, is going to be, at this point, u is equal to 1 plus 2 t naught. Okay, so in other words, if I run this back to that point there, I want to figure out what that t naught is. Well, that's algebraically, just it's a matter of solving the equations. X is equal to s, and t is equal to t naught e to the s. And I only need to know what t naught is. S doesn't appear up there. I only need to know what t naught is. So let's look at this. So I know that there's a couple of ways that I can do this. I know x is equal to s, so I know this is equal to t naught e to the s, and so it says t naught is equal to t. Sorry, I just wrote e to the s again. E to the x. It says t naught is equal to t e to the minus x. Okay, so for that generic point xt, u of xt is equal to 1 plus 2t naught, but this is t naught. This is going to be 1 plus 2t e to the minus x. Okay, again, just like for all the previous problems, please take some time and show that this function satisfies this problem. And again, it satisfies this not on some limited values of x and t, it satisfies this for all values of x and t. Again, if we set x is equal to 0, we have 1 plus 2t. That shows it satisfies this condition on our curve gamma. I just want you to show that it satisfies the differential equation. Okay, that's all for this one.